MCV4U1 Chapter 2, Session 5. In this session, we are going to work on Section 2.2 of the textbook, the derivatives of polynomial functions. We know the derivative of f of x, f prime of x, is limit of f of x plus h minus f of x over h as h approaches 0. The derivative of a function at a point represents the slope of the tangent line to the graph of the function at that point, which is the same as the instantaneous rate of change of the function at the point. Let's look at the horizontal line. The slope of the tangent line to the graph of a horizontal line at any point is 0. If you consider f of x equals -4, at point 3 and -4, the slope of the tangent line is 0. The constant function rule. If f of x equals k, when k is a constant, derivative of f of x is 0. F prime of x equals 0, or ddx of k is 0. F prime of x is limit of difference quotient as h approaches 0. F of x plus h is k. F of x is k. K minus k over h is 0. Therefore, the derivative is limit of 0 as h approaches 0. And we know limit of a constant as x approaches a is the same constant. So derivative of a constant function is 0. For example, derivative of f of x equals 5 is 0. Derivative of f of x equals pi over 2 is also 0. The power rule. If f of x equals x to the power of n, when n is a real number, then f prime of x is n x to the power of n minus 1. We prove this when n is a positive integer. We write the derivative, the definition of derivative. In this case, that would be limit of x plus h to the power of n minus xn over h as h approaches 0. We use the identity of an minus bn equals a minus b times an minus 1 plus an minus 2b plus bn minus 1, and we factor, we write it in the factored form. A is x plus h, b is x. X plus h minus x is h. We reduce it with h. And then we replace h by 0, substitution method. We have the derivative equals sum of xn minus 1 n times, which is n times xn minus 1. For example, derivative of f of x equals x7 is 7x6. n is 7. Derivative is 7 times 1, x to the power of 6. Derivative of g of x equals 1 over x3. 1 over x3 is x to the power of -3. Derivative would be -3, n is -3. X to the power of -3 minus 1, which is -3 x to the power of -4, which is the same as -3 over x4. Derivative of s equals t to the power of 3 over 2. n is 3 over 2. It's going to be 3 over 2, t to the power of 3 over 2 minus 1, which is 1 over 2. 3 over 2, t to the power of 1 over 2. Derivative of x is x to the power of 0. n is 1, and minus 1 is 0. So far, we learned derivative of a constant is 0, and derivative of xn is nx to the power of n minus 1. Don't forget, we proved derivative of x to the power of n is nx to the power of n minus 1, but it is always the same when n is a real number. If f of x equals k times g of x, where k is constant, f prime of x is k g prime of x. To prove this, we use first principle. F prime of x equals limit of f of x plus h minus f of x over h as h approaches 0. F of x plus h is k times g of x plus h, and f of x is k times g of x. This limit can be written as limit of k times g of x plus h minus g of x over h. One of the properties of the limits was limit of a constant times a function is the constant times limit of the function, which is k times the derivative of g of x. Therefore, derivative of 7x3, for example, is 7 times derivative of x3. Derivative of x3 is 3x2. Therefore, it's going to be 21x to the power of 2. Or derivative of 12 times 4x to the power of 3 is 12 times derivative of 4x to the power of 3. Derivative of 4x to the power of 4 over 3 is 4 over 3x to the power of 4 over 3 minus 1, which is 16x to the power of 1 over 3. Generally speaking, derivative of a x to the power of n, when a and n are real numbers, is a n x to the power of n minus 1, a times derivative of xn. The sum rule. Derivative of addition of two functions is addition of derivatives. The proof is very straightforward by writing the definition of derivative and substituting p of x plus q of x for f of x and splitting the limit. Knowing the limit of the addition is addition of limits, we can conclude f prime of x is p prime of x plus q prime of x. It is valid when instead of qx we put negative qx. Derivative of subtraction of two functions is subtraction of derivatives. For example, derivative of 3x2 minus 5 root x. We have subtraction of two functions. The derivative would be derivative of the first one minus derivative of the second one. First one is 3x2 and second one is 5 root x. This is going to be 6x minus 5 over 2x to the power of negative 1 over 2. The next example is derivative of y equals 3x plus 2 to the power of 2. We expand the function and we take the derivative of each terms. Derivative of 9x2 is 18x, derivative of 12x is 12, and derivative of 4 is 0. Our next example is writing the equation of the tangent line. As you know, to write the equation of the tangent line, we have to find the slope. We are looking for the equation of the tangent line to the graph of f of x equals negative x3 plus 3x2 minus 2 at x equals 1. F of 1 is 0. F prime of x is negative 3x2 plus 6x. Derivative of the addition of three functions is addition of derivatives. Therefore, the slope of the tangent line is 3. We use y minus y1 equals m times x minus x1, and we get y equals 3x minus 3. There is an activity in the book, or there is a solution using the graphing calculator. we put the function in and we ask to draw the tangent line at the given point and see the equation of the tangent line. The next question is determine the point on the graph of the previous example when the tangent line is horizontal. The tangent line is horizontal means the slope of the tangent line is 0. The slope is 0 where the derivative is 0. Derivative equal to 0, x is 0 or 2. Let's recap. The derivative of a constant function is called constant function rule is 0. Derivative of a power rule, f of x equals x to the power of n is nxn minus 1. dxn dx, Leibniz notation, is nxn minus 1. Derivative of a constant times a function is the constant times the derivative of the function. Using Leibniz notation, we have d dx of ky equals k times dy dx. Derivative of addition and subtraction of functions are addition and derivative of or subtraction of the derivative of functions. It's called sum rule and difference rule. To write the equation of the tangent line, we need the slope of the tangent line. We can find the slope of the tangent line by taking the derivative of the function using the rules in this section. To understand what we've done, work on the questions on exercise 2.2. Question number 1. Question number 2, part A, B, C, and D. Question number 3, part C and F. Question number 4, part C and F. Question number 5, part A. Question number 7, part C. Also, question number 11 and question number 16. Thanks for watching.